Namaskar my dear friends. So let us try to understand with a live example how we can design power supplies using PI Expert design tool. So this is a live tool. This is an online tool given by Power Integration, and we have already designed one power supply using INN3166C with 20 watt and 24 volt 0.833 ampere. Okay, so you can see this is our complete design that we have already done, and I'll show you how you can utilize the expertise or the powerful tool that is given by Power Integration through its website. So let us open the website. As you can come to your home page, you have lot of other options like start designing, solution finder, get tech support, everything. So once you log in, you try to go into start designing. I'll be like taking you up how to design with PI Expert tool. Okay, so once we click on start designing, it tells start a design with PI Expert, right? So you have to select your application. I am going to select my application as charger and adapters. Okay, then what is your output power? So output power I am going to select a range. Either you can select it 10 to 20 watt or 20 to 40 watt. So I will be taking upper side 20 to 40 watt. Then what is my input type? So input type we have like any input type or universal input type. So I will be taking universal input type, which will be 85 volt to 265 volt AC. Okay, then what is my topology? So my topology of design will be flyback. I have already decided it, so I'll like select flyback from the drop down menu. Then we will be taking isolated. So yes, we will be taking isolated design. Now once we click start designing, it will tell us to give some different window. Okay, so it has come to a different window and it will be giving you an options. As you can see, we have lot of options that is selected already. It has selected LYTSwitch 5, but our aim is to already select LYTSwitch 3. So I am going to select LYTSwitch 3 by default. Okay, so this is the device that is selected. These all are actually the options that is given based on your power input requirement that you had given in the first page. Okay, now coming to the fact that what is my product filter. So product filter, if you can see, we have product portfolio, and then we have charger adapter, we have output power, already we have seen. Input type is how many number of outputs we need. Okay, so you have to fill up all the information so that you don't land up in a problem later on. Okay, so I am going to select number of inputs, number of outputs as 1. Then isolated supply, yes, it is selected. Output type is, we will be either going to design a constant current control or constant voltage control, or both constant current as well as constant voltage control. So both will be there. Okay, then we have the flyback topology. We have high power factor or low THD. So I am going to select no, I don't need any high power factor correction right now. Okay, so it is not telling you any PI expert connected here. So we'll just change one more thing. Why it is not telling me? I'm going to select here LinkSwitch 3. Okay, then this is the device that we have selected. This is the device that we have selected. So there are possibilities that you may not have PI expert design for all the available power switches. Okay, so for that you have to understand which of the device that you have selected, so that it has a power expert design available. Okay, now everything is fine. We will now select this PI expert. So it will give you the complete design directly by asking you to give some of the inputs. So as you can see, it has very basic design of your power supply using PI expert design wizard. So it has flyback, it has LinkSwitch 3, it has LinkSwitch 3 CE family. Okay, it has package INSOP 24D, breakdown voltage of the IC is, or the MOSFET, inbuilt MOSFET is 650 volt. Now press next. Once we press next, we are going to have, it says minimum voltage input AC type is 85 volt and maximum is 265 volt. It has a line frequency of 50 hertz. It has AC defaults. Okay, and it has universal. So all these informations are there as a specification. Okay, now coming to the fact that next we have outputs. So as you can see, outputs, there is no voltage output, current output or power output. So what we have to do is you have to add one here. So once we add, then it will ask you what is your output voltage and what is your current rating. So output voltage I am going to put 24 volt as we have already talked about, and then current I will be putting a 0.833 ampere. Okay, so once you do that, it will automatically calculate the power rating. So that is going to be 19.99, approximately 20 watts. Okay, so once you see, it has already given you output voltage tolerance. So if you want, you can change this to 10, more than 10%, okay, or less than 10%. So I'm not going to change. Okay, so let it be 10% only. So 10% means 26.4 and minus 2.4 will be like 21.6 volt. So like that will be the tolerance. Okay, so once we have set the output voltage, you can see we have output voltage is this much, current is this much, and we have power rating as around 20 watts. Now cable drop compensation, I am going to keep it 0 itself. Right now I don't need it. As per my suggestion, you keep the design specification or the specifications input as low as possible, as simple as possible, so that you don't land up into very complex design. Okay, now as you can see, we have default components, all records. So you default set library or all records, it has a lot of components that is there in the library, so you can just keep it with as it is. Start with schematic, or you want other things. So I will start with schematic. I need schematic right now. What is my transformer type? Core material, it has selected 3F3. If you want, if you have already understanding of, then you can select other type, otherwise leave it by default. Okay, what I will do is I will select here SI unit, so that everything comes into mm or meter scale. Okay, good. So almost everything is done. If you want, you can have a preview or directly you can finish up. So once you finish up, it gives you a complete design of your schematic. As you can see here, schematic is being designed for you, and it is telling you what is the optimization. So optimization solution, see top 6 solution summaries. So it is not going to give you only one schematic, it is going to give you 6 solution. Out of 6 solution, any one of them or 2 of them you can select for your design. Okay. So this ns main range, so if you want, you can increase this number of solutions also, like 10 you can make, or 2 you can make, or whatever you want you can make it. Okay, so I'll just put OK. So you can see this is the circuit that is already there. Now I'll just explain you what is happening here. It is still loading, around 25% is done. So as you can see, it has selected solution 1, okay, with the device it has selected as INN 3164. My aim is to go ahead with INN 3166 because I don't want to have any like very tight tolerance or something, so it will be better. Okay, so I will be selecting 3166 later on. I will show you how. However, just keep it the first one. Okay, so once we have kept the first one or second, anyone you can take. Okay, not a problem. So let's say if you select second one, it will give you second one. If you select third one, it will give you third one. So better let's select INN 3165, little bit higher power rating IC. 3164 is lower rating, 3165 is higher rating, and 3166 is even much higher rating. Okay. Okay, so if it is green button like optimization done, then you will see that your design is complete and your design is good to go ahead. So as you can see, the device that is taken is INN 3165CH101. Okay, and you can see the best part of this particular circuit is, okay, best part of this particular circuit is what is my bridge rectifier, what is my CMC common mode choke, what is my capacitor, everything is there. We have our snubber circuit design, we have our transformer design, we have our SR FET design, or this is basically, this can be also designed with your a diode. Through here you can put diode and one RC snubber, but here they are using MOSFET as like SR FET. Now we have output, like a capacitor and filters, and this is my feedback. Feedback is going so that it can control the like output voltage, and there is one more feedback which will be there with your current sense resistor, that will be your current control device. Okay, so this is how a complete design is there. Now you can see this is the schematic, this is my design result. So design result, it is going to give you the power supply specification complete. Okay, same specifications you can see in your DER, like design example reports, that is given by power integration, and complete report is there. We have board layout also given, like top side and bottom side, everything it will be given. And if you want, it has given a little bit of like summaries and tips as well, like where to put what components. Okay, similar to that, it has given you bill of materials as well. I will tell you how to optimize this bill of material later on, because directly selecting this particular components and taking it is may not be suggested, because this may be an older components, or this may be not very optimal components that is available in the market. Okay, we have magnetics designer. So as you can see, we have the transformer input rating, output primary winding, secondary winding, everything. And this is the transformer that is given complete, like pin number 1 2 3 4 5 6, and this is secondary side, this is primary side, and this is my auxiliary side. Okay, so this is the complete magnetic design. This is design evaluation. So if you want to evaluate your design, it is going to give you what is the complete losses that is there. So in pie chart, it is going to tell you what is my losses, like 18%, 12%, and their legends are down. Okay, so we have a percentage loss of, like let us make it little smaller, so you can see we have rectifier loss or something like that. So this is what is happening. If you want, you can make it little bigger and see what is happening here. So input bridge rectifier loss, conduction loss, copper loss, everything is there. Okay, so this is how complete loss you can see. Then design notes, if you want to like write down some notes by yourself. Let us say I am going to keep V out is equal to 24 volt, and I out is equal to 0.833 ampere. Okay, so this is my design note. It is a flyback and isolated. So I think this much is enough. Okay, like if you want, you can put more notes for yourself, so that, or otherwise if you have any like a specification that is there for this particular design, you can upload a PDF so that you can keep it saved in your design. Now let us go to a very important thing. This is complete, and what you can do is you can go to file, you can go to file, and you can export to PDF. Okay, so export to PDF, or export all to PDF, or export schematic. So everything is available for you. You can like take your schematic as it is, and this will be your complete circuit design. Okay, so this is very simple understanding of how to like go ahead with your PI expert design tool. Now a little bit more advanced in this, what we will do is we'll try to like optimize some of the like parts. Let us say I want to I have already decided my like ano switch. Okay, so I am going to change this switch to some other one. Okay, so what I'll do is PI device selection. So PI device selection, you go ahead. Okay, and I am going to select the device, some other device. So I am going to select INN 3166C. Okay, so I am going to select that one, and I'll put OK. So as you can see, my design is still green, and that particular device will be changed to uh, this device. Okay, so 3166, and as you can see, the color is changed. So whenever there is a blue color, it means it is given by you. Okay, and whenever it is black color, it is by that PI expert design tool. Okay, so this is how the understanding should be. Now what I want is, I want like little bit more capacitance here. Let's say one more I want capacitance, and I want to increase the capacitance value, output capacitance value. So for that, what you can do is, you have other like a specification, design, input selection, input sections, PI device, under voltage, like over voltage, heat sink, everything is there. Okay, IS-pin circuit, everything is there. Snubber is there. Then we have core selection, bobbin selection. All the selections you can still do a different design. You don't have to worry about that. Once you have given, everything is fine. No. Okay. So I'll go to post filter. Okay. And in this post filter we can see output stage. I am going to go to capacitor. Capacitor I want to change it to little bit higher values. Okay. So what I'll do is I'll go here and I'll change it to another values. Okay. So let us say I want to have like two values. So just go to edit, make it two values. Okay. And the capacitance value, what you can do is ripple is, let's say, 4%. Capacitance value, what I'll do is I'll just change it to some other value. Okay. So instead of 68 microfarad, I'm going to have, let's say, 220 microfarad. Okay. So I'm going to select 220 microfarad with 50 volt rating, or if you want other voltage also you can do. Okay. Okay. So 50 volt rating with 220 volt like microfarad. So there will be two capacitor that will be available at your design. Okay. So as you can see now the schematic. Okay, so the schematic that is shown here is, let us see. So yeah, it has made 220 microfarad. Okay, since it took only one capacitor, I'll just make it two and then I'll show it to you like how you can have two capacitors. So again go to the capacitor. Okay, there might have been some thing that is missed. Output stage, go to capacitor and make here C out one parallel. I'll make it. Okay, so I'll just change it and I am going to put output capacitor as 2. Okay, and then there will be two capacitor that will be available there. Okay. Make it parallel, so both will be parallel to each other and there will be two capacitor connected, 220 microfarad there. But however at the end you have to understand the design passed must be there, otherwise if your design is not passed it means your design changes is not correct. Okay, so as you can see there are two capacitors. Similar to that, if you want you can change your like feedback resistor so that you can have a proper feedback on your own, maybe your own choice of available values or something like that. So it will automatically change your one value. If you change, another value will be calculated and change it. So let's say I am going to change this to 100 kilo ohm. Okay, so for that what I will do is I'll go either click directly also, no problem. Okay, or otherwise you can go to left side and change by putting that value. Okay. So RF1 and RF2, so RF2 I am going to change it. Okay, so RF2 I am going to change. Okay, what I will do is it is not changing. Change it. Okay, so if you change okay, it is not allowing you because it has already calculated the exact like output voltage based on the like based on the output voltage. What is the feedback voltage? Let's say 1.265 volt is there, I think, I guess in the device. So that's the reason it has kept it. But however I'll tell you like how to design when I have designed already this particular schematic. Here you can see we have kept 100 kilo ohm, so accordingly I have changed it to 5.6 kilo ohm. So I'll tell you how to design this particular values through our Excel sheet or maybe through the data sheet comparison. Okay, so this is how we can do. So alright guys, I hope you have understood the complete understanding of this particular live example, how we can design by giving our specifications, our input type, our topology type, how we can change our like device selection, and at the end we have lot of specifications. Based on that, lot of like components has been already populated here. If you want, you can have a possibility to change the values of each of the like parts. Okay, so this is how you have a good understanding, hope. If you do have still questions or anything regarding the like schematic design using PI expert for your any of the values, or how to select a particular component at the beginning itself, or what is the main criteria to like select a particular component and design your AC/DC converters, You can put down your queries in the comment box and I shall be able to answer you out. Thank you so much. Hope you enjoyed it.